Welcome to Thermodynamics Thursday on Curly Carbocation. If you like short-form chemistry and chemical engineering content, please subscribe and stay tuned. Thermodynamics will explore heat transfer with and without mass flow. So you got an open system, a closed system, and an isolated system. An open system allows mass and heat to transfer through it. A closed system only allows heat to transfer through it. And an isolated system is something that we cannot get to, but it does not allow any heat or any mass to transfer in and out of it. And that Stanley Cup that kept ice cold in a car fire is just a very, very good closed system, but it cannot be truly isolated. Stanley, please hire my husband or me when I graduate. Now, energy can move without mass moving, but sometimes you do need mass to move. There's a lot of pistons in this class, so get used to that, aka pressure ratios. You're gonna get a whole new set of vocabulary, such as adiabatic, isentropic, isochoric, isobaric, and isothermal. Make sure you understand the difference between adiabatic and isothermal because this will drive how you do the math. And speaking of math, this class is a ton of algebra. In thermodynamics, you're going to calculate efficiencies a lot, and not all the time is optimal efficiency actually 100% efficiency. Sometimes it might even be 60%. Honestly, it could even be 15%. At least in my textbook, the lowercase Greek letter eta is what denoted efficiency. And calculating optimal efficiency before you even make anything is your guide in determining whether or not you should actually pursue this. Because if it's not going to be very efficient, even at its optimal levels, why would you even pursue it? Because you're not going to make money off of it. And we're not going to suffer through thermodynamics without making money afterward, right? In this class, you need to learn how to draw boundaries and which side to stand on because your perspective is going to determine the math. Another thing you're gonna get used to is the thermodynamic tables, but you'll typically be started out with steam tables, and a tool that you need with steam tables is linear interpolation. This does the heavy work, and then this helps you to get even closer to the point that you want. Steam tables are typically in the back of your textbook, so make sure that you know how to find what you're looking for when you're reading a problem. And if this seems like a lot of work, either get out or lock in, because if you're not gonna be dedicated enough, I assure you, someone else would gladly take your spot and gladly take your aid money that you're wasting. As my own thermodynamics professor said, people will tell you, wait until thermodynamics, and then wait until senior design, and then wait until the real world. And I assure you, the real world is far more difficult than engineering school. Because instead of a bad grade when you get the answer wrong, you actually lose your license and get sued. Thanks for watching. Please be sure to share this with a student who will need it. Mechanical and chemical engineers both take this class. I will see you in my next video. Bye guys.